Hello and welcome. My name is Shannon Kemp, and I'm the Chief Digital Officer for DATAVERSITY. We want to thank you for joining the latest in the monthly webinar series, Data Architecture Strategies with Donna Burbank. Today, Donna will discuss where data models fit in today's modern data architecture. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we will be collecting them via the Q&A panel. And if you'd like to chat with us or with each other, we certainly encourage you to do so. And just to note, the chat defaults to send to just the panelists, but you may absolutely change that to network with everyone. To open the chat and the Q&A panels, you can find those icons in the bottom middle of your screen to enable those features. And as always, we will send a follow-up email within 2 business days containing links to the slides, the recording of the session, and any additional information requested throughout the webinar. And now let me introduce to you the speaker of the series, Donna Burbank. Donna is a recognized industry expert in information management with over 20 years of experience helping organizations enrich their business opportunities through data and information. She currently is Managing Director of Global Data Strategy Limited, where she assists organizations around the globe in driving value from their data. And with that, let me give the floor to Donna to begin her presentation. Donna, hello and welcome.
Hello, thank you so much. Good to have you back, Shannon. We've had other folks in the last few, so it's nice to hear your voice. And for those of you who are new to this series, it is a series. Dataversity is very good about keeping all of the previous sessions recorded on their website. We also link to these on our website from Global Data Strategy. So if any of the previous ones in this session look of interest to you, you are able to catch them, and we hope you can join some of the ones upcoming the rest of this year. So it's always nice to see some familiar names on the link. We get some of the same folks each time, which is great. So, but to the topic at hand, we're going to talk about data models, and I'll be curious about the chat. Folks tend to be very passionate about data models, about how they're done, whether they're done, who does them, how they're built. And so, whenever we do a data model themed webinar at Dataversity, it tends to be well attended and with some, good input. So we will try to leave some time for questions and discussion at the end. But I wanted to have this webinar in particular because things are changing so much in the industry, which keeps it fun in data. So much going on between artificial intelligence and advanced analytics and big data and all of the new things, or some of those aren't even new anymore, right? Do we still need data models, or do we need data models even more? Or some of you might say, what is a data model? That's why I'm here, which is we should answer all of the above. So kind of want to give it thought. I think of this a lot in my own practice, which is global data strategy, where we use data models all the time in both data strategies, also in implementation, and we'll touch on that. I try to do that, not to just give a blatant plug to our practice, but because I think what's helpful in these sessions is that real world experience of, hey, we actually did this, or this client of ours did this, or this is where it works, this is where it doesn't. And I think that's part of the value of these sessions. So we'll throw some of that flavor in there. But as a data architect, data modeler myself, love to start me with a good definition. And of course, a lot of us here are from DAMA or DAMA, and are involved in either the DAMA DMBOK or the DAMA Data Dictionary, which I tend to use a lot. So I wanted to take the definition from there firstly, which is one that I like. So when you see, this is way back from Brackett in 2011, but I think it was well thought through. What is a data model? It includes formal data names. And we'll talk more in this session about, is that a business name? What do we mean by a customer? Is a customer the same as a client? Is it a formal data naming convention? Is it CUST_num for cust number? Do we have naming conventions, right? Comprehensive data definitions, which a lot of us spend time when we're talking about from the logical or business side of things. What do we mean by a such and such, which is critical to data modeling? Proper data structures, right? Especially when we are talking at the physical data model side. How do we create, in many cases, a physical table to store this information? Not always a table, but often. And then the precise data integrity rules. I like that clarification too, because the reason we do data models is to create quality, well understood, well structured data. And we'll talk about there are many modeling notations, flavors, styles. Relational data modeling is one that's very common, and good old-fashioned third normal form that we'll talk a little bit about. And some of the benefit of that is that there's embedded data integrity in that modeling notation, right? So this isn't a theoretical activity. We're not just doing it for fun. Many of you who know me know I am nerdy enough that I do find it fun, and some of us do, right? But that's not why we're doing it. I also like to ski, right? So if it didn't actually have a practical use, I probably wouldn't be doing data modeling at all. But it does, and it creates these structured business rules and data integrity rules for data quality that actually actively drive the enterprise, which is great. And a complete data model must include all four of these components. And I like that clarification as well. We've all seen a data model from someone. Of course, it would never be us, but yeah, there's a table there with columns in it, but it's called, I don't know, entity one, entity two, right? There's no data name, or it's location, but there's no definition. Is what location is that? What does that mean? Or it's structured incorrectly, so the performance is bad, or there's no referential integrity, et cetera, right? So I thought that was well thought through. And I'm always a fan of using DAMA where I can. I'm also a fan, you've heard me on these webinars talk about the Gartner IT glossary, and I like their clarification as well. Data modeling is a family of techniques used to describe kinds of information that are important to an enterprise. And I think they're doing a nod to a lot of what we'll talk about in this webinar, is that formal data modeling originally emerged to meet the demands of a database designer. And often that was a relational model, right? I'm going to create a table. What structure do I make the table, right? It's not only that anymore. It is that and. So I've built data models and do all the time. We'll talk about that. I don't want to say just, but because it's important. But from the business side, what do we mean by these terms? What's our customer hierarchy? How does our product data structure work? Those are business discussions that have nothing to do with a database. My products are structured a certain way, whether they're in a database or not, right? And not everything is a database. There's XML formats, there's graph pattern, or different types of databases. How's that? We could have a whole webinar of what's a database. We can get philosophical, and we're trying not to. But I thought the combination of those two really touches on some of the beauty of what is a data model and how it can help. So moving ahead, there are types of data models and different levels. So at the business level, I would say, that's where we're talking about kind of the conceptual and logical data model. Often a very large enterprise might have this idea of, an enterprise model where it's just your high level subject areas, like customer, like product. There could be dozens of entities just in some of those subject areas in a really complex org. But I'll speak mostly at those kind of blue areas. The conceptual, which is kind of a terrible name for a really wonderful thing, which is, what are these core concepts of the business that are driving our organization, and how do we define them? And I know, why the word conceptual is unfortunate. It can seem theoretical until you get in a room with the business. And if you're a technical person on the call and haven't, and I know the business is a very broad term, those are the folks that generally love these and will hone right in onto this concept if you get the right example of, what do we mean by a product? Do we include components in a product? Are there wholesale products? Are virtual products, or are they something else, right? You're really getting to the core of what they do for a living. And that's why it's important, and graphing it out in a very logical way gives you lots of credit, right? Logical is also at the business level. You're getting a little more detailed there. This pyramid is kind of meant by design of general, conceptual data model, even at a large firm, should fit on one page, right? It's your core, and it's hard to keep it simple. I know in our practice, we're always kind of guilty of that, going right down into the logical a little too quickly. But, a conceptual is, what is a customer? What is a product? What is a student? What is a patient? All of that. And then logical gets down into those more. There may be, several entities describing a product or a product hierarchy. There's attributes, there's data types and things like that. And then physical is you may have thousands of tables. Look at a modern ERP system. There are thousands of tables and often very complicated naming constructs that are very difficult to understand, which is why you need that logical and conceptual to really get that benefit. But the business should be more simple, fewer entities, and then your physical gets kind of higher volume as we go down. Just kind of, I love to throw graphs in there. You may have been on calls where we talk, global data strategy and DATAVERSITY have partnered in the past to do some surveys. And I like this because it really hits in on people in the real world. Often folks like you who attend these webinars take this survey and we say, in the real world, what do you use? And it tends to switch from year to year. Either is conceptual first and logical second, or logical first and conceptual second. But it generally tends to be the businessy ones that are at the top, which I'm a big fan of. I also wanted to see everyone doing physical data models, but you'll see that those are of all the types of data of models people can use in an enterprise architecture. This isn't just data. It's kind of your business level and then your physical data models as well. Okay, so I'm going to break the webinar into those two kind of flavors or patterns of data model, and I'll start with the business level, which is that conceptual or logical or both. I'll start with maybe more of a strategic lens on this. You'll see it's in our like the company I work for, in the name Global Data Strategy, looking at data in a strategic way. And you might say, really, Donna, it's a data model webinar. Why are we talking about strategy? But I have, so we sort of fell into this in some of our projects naturally, and now we do it almost all the time of that as part of a data modeling exercise, kind of by accident. We're working with the business and it became almost existential of the business. What do we mean by a customer? What kind of customers are we targeting? Is it only B2B? Are we also looking B2C or looking at the consumers within a company? Should we track both? What are the buying patterns? What do we mean by a product? Do we really think of our components as products? Or, it was just naturally as we're talking about these seemingly theoretical, entities on a diagram, folks were discussing the business, right? So I found that exciting, and now I do it all the time. And I would do this. I can't help it if someone's describing their business to me. I tend to put it in a model because that data model describes a business really. And so if you're getting those conversations, you're doing it right. And yeah, I'll talk more about that. But to me, that's exciting, and that's really what these models are meant for. So I'll just go through some examples. Names protected for the innocent, although these are all positive. So, and these are one, gosh, all the time, but I could spend a whole webinar on this and I won't. I just picked two that are a little bit different. So we were talking about a consumer electronics company, and they were doing an enterprise data model as part of just reporting on a product. And of course, we have that classic debate. What is a product? What do we include in a product? And there was some really good discussion of, well, yeah, something that generates revenue, something that's on our website, doesn't have a product number. Do we report on it? Well, of course, our physical products, we're selling, an electronic device. That's kind of our core business. Well, there's actually some virtual products we sell. There's software that drives that. There's subscriptions to trainings and things like that that are actually virtual, but they're a product. And there's also services, whether it's support or training or, they're things we both sell. And could we bundle them? And are we tracking them? And should we be tracking them differently? And it was a whole conversation of business people in a room kind of, and to me it was still talking about, I'm thinking super types, subtypes and things like that, and how it might turn into a dimensional model for reporting. But they were really thinking of, wow, yeah, what does drive our business? Could we be pushing the virtual products more? Is a virtual product as much as a product as a physical product? Are services a product? We're a consultancy in my company, we consider it, but for a product company, maybe a service isn't a product. It's something we track, but it's a different thing than a product. I'll leave it up in the air of what they actually came up with, but I thought it was a healthy discussion that really was about who are we? Who are we as a company, and what's driving our business forward, and what do we focus on and what do we report on, right? Because what's that classic, you can't manage what you can't measure. When you're measuring something in a report, those are typically the core things driving your business, right? I'll pick another one. If you've heard me talk, I always like to try to get beyond just customer product, although we always relate to that because we're all consumers and buy things. But some either nonprofits or non-customer and products. So universities, we seem to be doing a lot with universities, which is great. So this was a university we worked with. And we were doing data models and process models and really helping the data architecture department, really modernize how they were storing the data. And again, we were doing workshops with, it was kind of fun. We had, students, we had IT people, we had professors, we had everyone, we had, I don't know, student services. And I don't want to say by accident, but maybe just naturally, organically, we started to even get into what do we mean by a classroom? Is a classroom a physical thing in a building? Or is an online classroom still a classroom? And then similarly, what's a course? Is it the course? Is the curriculum? Is it a mode of is it? And then, I won't bore you all day, but what is a student? Is someone online at night really the same type of student as someone on campus? One might be 18, one might be deployed overseas in the military. They have very different experiences. And again, it became kind of existential. And in this particular university, IT was one of the, we took kind of a survey later, was one of the biggest proponents of this. They were saying, we never really understood the student or even what we did as an organization so well until we had these workshops. And they were really, it wasn't only because of the data model. I don't want to take credit for their whole, university strategy, but it did shape it in terms of, are we a digital first university or are we a campus first? And how do those two worlds blend? And there were conversations of, and they sort of limited it before you were sort of one or the other. Does it have to be? Can I be an on-campus student also taking online, or can I be an online and sit in on some labs and things like that? So anyway, I could go all day on that, but I think these are just two examples of things that if you get the wrong example, and we tend to do this as data modelers, and I've already done it. We love to get really academic and be like, what do you mean by and you can very quickly start to become annoying if you do it with everything, or you don't understand the business first. So whenever we go and do a data modeling session, we've done a whole lot of research. If any of my consultants are on the call, they'll be cringing because they know, like, did you read the company report? Did you go to the website? Do you really understand the org? Because if you don't, you can't be doing a data model. You don't buy a book. You don't buy a book of data models and just take one. You don't just buy an industry model and just take it. Yeah, yes, they can inform you, and we'll talk about that. But the purpose of data modeling is to really understand the organization, its rules, and all those nuances. So, two business examples. So, the necessity of data models. Do we still need this in today's modern architecture? I'll be bold. I say if you want to communicate effectively, you need a data model, right? And I do think it's helped me in life of being very more clear of where, one of my clients, and I'm going to make a t-shirt out of it one of these days. She likes to say words mean things, right? So we need to be clear in the data model. If we're talking to each other, what do we mean? This also links to glossary and data catalog and things. But this is also true. I would argue it's even more true for machine interactions, right? I'm talking to a person and it's a salesperson and they're talking about a customer. I know it's really a prospect because they haven't bought yet, but I'm not going to correct them. I kind of know. A computer doesn't know. They don't have that nuance. You need to be very literal in terms of both structure and meaning and semantics. So again, that's really where a data model comes in. So technical level, I could go all day in the business side, and we've had webinars just on that. I think when we talk about the modern data architectures of today, the technical side is really where it gets complicated because it's exciting. I mean, I feel, I've been in this industry, gosh, 30 years now, practically, and I still feel like a newbie, even though so many of the core things are fundamental. I learned them in university, even AI, a lot of those fundamentals were taught back then. We have new tools. But gosh, everything changes so fast. It's in trying to keep track of what's still fundamental and what is truly changed. And a data model is part of that. Where does it still make sense and where does it not? So hopefully you're interested as well. This is a very complicated diagram, and it is an indicative example. I'm sure the architects in the call may be cringing on how we did some of the lines and are we missing something? And probably. It's just an example for illustrative purposes. Where you'll see this is the complexity and the fun of being a modern data architect. It is still true, but also in the old days, it was a lot of, we had relational data sources, we turned that into a warehouse and we reported on it. That was hard enough, right? Now, and maybe in the past we had some of this as well, but we have sensor data and video and documents and we need to do AI and machine learning, and we want to do facial recognition and all of these things. And there's external data sets, and people are competing on monetizing data sets and Internet of Things and Internet outside of, so there's so much going on. How do we both architect our organization, which is not the purpose of this call, but what does a business data model still make sense? Where do data models make sense in this very complicated, evolving ecosystem? So I'm going to go through this and kind of give you my 2 cents on this as we go. So I'm gonna start with a tried and true. Still, yes, they make sense. I'll fight you in the hallway. I say this all the time, even though I'm a terrible fighter, so don't really do that up loose. But I will fight you verbally in the hallway. That relational data models still are very valuable for the use cases in which they apply, which is one of them is this, your kind of operational data sources. What a relational data model is good for, if you think back to that initial DAMA definition in the beginning, is that consistency, data quality, referential integrity. For those of you who aren't familiar with third normal form or 3NF, a simple version is, how do we keep things consistent and stored in a way in the database that enforce that, right? So the easiest way to think of this, and that second bullet, if you've heard me speak, you've probably heard me rant about this, and I think I've already said I've ruined my family and friends, that once you see this, you'll start to see data issues in all of your negative customer experiences. So often it is a data thing, right? So I don't know, if there's bad data quality, can we have the right drop-down list for, I don't know, state codes or gender codes or whatever we've defined? I mean, one of my favorite, back in the Twitter days, I actually tweeted about this. I was registering for a webinar on data quality, and there were no like the state I lived in the US was a free text field. I'm like, okay, that's almost funny. Like, you want to have bad data quality, do a free text field. How do you not have a free text field and have a drop-down list? Typically, that's a relational database with some sort of referential integrity. You'll see here here's an example of, a customer can have a gender. In this case, this particular client, it's biological gender only, and there's only two values, M or F, male or female. And that's enforced through that referential integrity. Also, business rules. Can a customer have more than one account? I'm almost getting like sweats. My parents are older and I help them a lot with their banking and online. And almost each one of these business rules they've had an issue with. Can a customer have more than one address? Can more than one customer be listed on an account? Can a customer at a bank have both a checking and a savings and not have the bank get confused about that, right? All of these things that are inherent business rules in your data are typically driven by a data model. And so I've heard it all, been around. That blue box in the bottom, I do hear folks saying, well, we don't need to do this. We bought an ERP, a CRM, or billing system, or whatever you purchased. That just does it for us, right? And that may be true, but there is a data model, whether you're looking at it explicitly or not. And I ask you, do these business rules and data model match your organization? It may be a 99% do and 1% don't, or 80 do and 20 don't, but I bet you it's that 1% or 20% that's going to drive you crazy for the rest of your existence in the company and cause problems. So it doesn't mean you shouldn't buy a CRM or an ERP. I'm absolutely not saying that, but just don't take anything verbatim. Or even I gave a little jab earlier to purchased industry models. It's not a bad idea if you're a bank to look at a banking model that's been built. But if it were banking were that easy that you just all banks were the same and we just clicked a button and ran a bank, you probably wouldn't have your strategic differentiator. So typically, even the same, some of the things you do that are different in your org are going to be expressed through the model. We allow our banking accounts to have 1,000 people on the account, and people can have 1,000 accounts, and other banks it's a one-to-one. I just made that up. It doesn't really make sense, right? But I've found that and I've experienced them. And again, you'll start ranting about your customer experiences. It's good a data model exercise of, gosh, I think I've complained before. I have both a PO box and a physical address. The amount of organizations that still can't get that right, that your billing address and your physical address are different. I see that all the time in organizations, supplier addresses, and what types of physical shipping addresses and things. So all of these things are complex, and modeling them out, and especially modeling them out ahead of time before you implement. One of my success stories, we were working with an organization. It was actually a nonprofit that was looking to purchase a fairly expensive ERP system. And we encouraged that they do the data model first, and make sure that this ERP system matched their data model. They actually went in the purchasing process to the ERP vendor and said, does your model work this way? Sales rep was shocked, probably the first customer that ever showed them a data model. And they said, we're not buying it unless you can do it this way. And it did take a customization of the system. They were able to do it, but the fact that they did that up front, and I kind of find this a fun example that this was the finance department that did that. Their implementation. It was a nonprofit that was fairly small, so their implementation took a month and it was seamless. Another group, which was HR, didn't do that. They're still years later trying to fix their implementation because it's the data model of the HR system, which I've seen successfully work in other companies, but it didn't match their way of working, right? So, not that you always have to go in your procurement would probably think you're strange, although you may be right to go into the procurement process with your data model. But think of that before you implement, because it does the rule. There is a data model in this system. Does it match what you are trying to do? So that's your good old relational database. So documents, gosh, this could be a whole webinar as well, but they're multifaceted. In one sense, they can be a source for the business rules that define data models. There's probably somewhere in your different SOPs or processes. Can a customer have more than one account? Can accounts be owned by more than one customer? What's the process of adding someone to your bank account, et cetera, et cetera? You will find some of those rules in your documents. In fact, we as consultants do that all the time. We look at websites, we look at documents, and we generally put together a draft data model that's probably 80% good from just documents that have been there. And again, if you've seen my webinars, you've seen this. I find this fun. I was, full disclosure, I liked modeling sentences when I was a kid. I knew I was destined to be a data person back then in third grade or whatever it was. So an easy way to do that is take these sentences in your documents, start putting boxes around the nouns, department, employee, location, customer, client, patient, student, all those types of things, and then start underlying the nouns. And for this example, you can have, a department employees, and an employee can work for a different department. This isn't a whole data modeling class, but there's cardinality, right? And so in here, a department can have many employees. An employee can only bill to one department. That may not be the business rule. In fact, you may have heard me rant about this one before. I was back in the day when I worked for a software company, I would do consulting. I would go on a business trip and I would do consulting to help a client implement. I might be doing some pre-sales with the sales department, and I might be doing some, post-sales just advisor, right? So those were three different departments I was quote billing to on my trip. But the ERP they were using didn't let me do that, and trying to get my billing and my expenses and everything done, because the business rule was no, an employee only works for one department. Well, that wasn't true for me, and the amount of pain and suffering that I had to go through and workarounds and doing separate timesheets and crazy things for a simple business rule like that, right? So again, when you have a problem with some of your systems, just think, is this maybe a business rule? Is it a cardinality rule? Is it a definition rule? Is it et cetera? So again, if you're building data models, documents can be a fun way to kind of start there. Okay, documents, and so had to put this in there. In the age of AI, documents are becoming more and more important in an organization. I've for many years kind of wondered, we have so many silos in our technical environment, why kind of the document management folks and the data management people never talked. They kind of talking about the same information. Just full disclosure, when we're talking about, or clarification, not disclosure, when we're talking about large language models or LLM, that type of model, and words mean things, right? Those type of models are analytic models. They're not prescriptive, descriptive models like we're using in a data model to create a data structure or create a business rule. However, they're more inferring information. But I thought I would throw it out there because it's so huge and because documents are becoming so ubiquitous and more important when we're looking at things like LLM. And so a couple things, just again, this isn't an AI webinar, but just think about that. Are you training what is the source of LL, your chat GPT? I'm trying to understand if a customer has more than one account. I'm not going to go to a generic chat GPT and ask the internet, right? Because now you're going to get kind of this generic answer for maybe, right? But you need to train it on your documents, your model, your information, maybe obvious. Do we trust that? You could take a shot at trying to generate some data models from AI and things like that. So it is a different thing. It is a related thing. Data models, analytic models more infer or use mathematical modeling to create information or generate insights, whereas the models we're talking about are creating the structure. So if that makes sense. Okay, moving ahead, this is like, just a whirlwind tour of all these different areas of data models, just to get your brain thinking. This isn't a class, this isn't a final answer, but just to think about it. So in a typical, say we're thinking of your kind of data warehouse or data lakehouse environment, we talked about operational data stores kind of on the left there, right? My ERPs, my order systems, et cetera, et cetera. Typically, you land that in its raw format before you format that for reporting. So you can also do quote unstructured data. We'll talk about that as any data unstructured, but in this case, it's your raw landing area. So typically, you would land the application just like it was formatted at source. So those data models I showed a few slides back, that's kind of what it's going to look like in your raw landing area, which can be typical, relational, but you can in a data lake house or a data lake, you can also put other formats. It isn't only structured databases. So just going through kind of your classic data warehouse type example, often if you're going to do certain reports like show me all product sales by region by customer, whenever you kind of hear those words report on something by something else, I start to think star schema, which is still very relevant, used all the time for this particular use case, right? So often you'll put that in a data warehouse, which has things like facts and dimensions. I'm a proponent of using something like a business friendly semantic layer. And then, your consumption pattern is going to be some sort of business intelligence reporting tool or even a spreadsheet, but, a Power BI, a Tableau, that type of thing. All of those layers tend to think often in your star schema kind of cube type format. Which is more your dimensional model. So a simple way of looking at that, if this is new to you, again, when you're reporting on something by something else, your facts are the things you're measuring. So in this case, total revenue by year. That's going to be a very, a lot of rows in that table of every time someone purchased something, you're going to get that row and kind of calculating up your revenue. And then you want to slice it and dice it by those different nouns we talked about, right? Right. Again, we're drawing boxes around the nouns. So I want to report on revenue by customer, by product, by sales rep, by region, by month. Those tends to be your dimensions. Why it's called a star schema is it tends to look like a star if you lay it out that way with your fact in the middle, and your dimensions. This isn't again, a class on dimensional data modeling, but the beauty of this is that you should be able to have what we would call a conformed dimension or a reusable dimension. Now that I have customer, instead of revenue by customer, I might want to know sentiment by customer or store visits by customer or a lot of things customers do, but you only need one customer dimension table. So modeling it out causes that you don't, and I've been seeing it more and more, a slight Donna rant, I can't help it, I do. A lot of these BI tools way over here on the right are really good, and they're so much easier than in the old days that you can kind of consume data right from source and load it all in and start modeling. Eventually, you got to have scalability problems. So we generally always recommend as soon as you start to get any sort of you're beyond a pilot, start putting it in a warehouse or a mart, and the semantic layer is a nice addition to that. It's hard to have those true reusability conformed dimensions when you're doing everything at that kind of BI level or everyone's doing their own report. They can be deceptively easy to get yourself into a whole lot of trouble. That's why these models, it really promotes the reuse. It might be quicker pilot number 1 to do it in the BI tool, but pilot number 20, having that warehouse makes it a whole lot easier. And definitely that semantic layer promotes reuse. So that's your dimensional or star schema model. Moving ahead in our kind of whirlwind tour of a modern data architecture and where data models fit, kind of put that unstructured in quote. So yeah, we think of audio files, video files. They're not stored in a relational database. You don't have state tables and columns, but anything digitally, if you want to take it to its logical extreme, it's stored in a digital format. There is some structure to it that. So one way that is tracked when you think of things like facial recognition or understanding, some of these digital searches and things like that is this idea of a vector database where those are stored in a way to be able to better map and understand things like video files so that you can do your advanced analytics and search and things on that. So not everything, even though we talked a lot about relational databases and warehouse and things, that's not the only solution, especially anymore nowadays, right? So this idea, and again, probably I'm not looking right now at the chat, but all of this is probably, but what about this and what about this? And I'm probably say, yep. But these are just some examples. So um, when you think of something like an image, and it's kind of fun if anyone uses some of these tools nowadays, and I think this came from an actual example I did it. Find me a picture of a green frog and a bicycle, and it can kind of generate these pictures or find these pictures in a database. And so there's a couple things. And if you think back to the definition in the beginning of what a data model is, it's both structure and meaning, right? So it's not enough to just take the picture. A picture is just pixels, and you to create these and make them into numerical vectors. You kind of map out that picture, but you also have to have the meaning in that, the semantics in it, and that's where these vector databases can help. It's not only pictures; it can be used for molecular structures and things like that. But it helps with both that semantic and what these data points mean. So I know that this thing is a green frog on a bicycle, not just a bunch of pixels with colors, right? So that isn't maybe what we typically, a lot of us data architects think of when we think of a data model, but it has semantics and it has structure. Okay, moving right along in the whirlwind of data models. Master data, that's kind of your golden nuggets of your core information that some of the same information we've been talking about that are going to be in your relational systems and going to be in your data warehouse, but they're stored in this particularly special area that's called master data, that are cleaned, deduplicated, rules applied, and a data model is perfect for that, right? I want to have my single source of truth for my customers, my products, my vendors, and just like everything else we've been talking about, there's a structure to it. So think I'm a B2B customer. Is it just a company I'm working with? Do companies have parent companies? Do I need to understand that distinction? Do we need to link all the offices? Right. So there's hierarchies with a product. Is it a brand and a product and a branded product, or a SKU level item? Are there components of that? All those hierarchies, all those business rules, all those structures, and then even the semantics. Is it vendor? Is it a supplier? Is the supplier the same as a vendor? Et cetera, et cetera, et cetera. So that all gets done in the master data. This one, it's both relational. You want that relational. Often what you can do too in the operational system is a lot of these lookup values, right? I want to have my list of state codes, which is my reference data, can be prompted from these master data lists, right? So you can do some of that with your referential integrity of a customer, can have more than one address, which can have more than one region, which is your states. Customer can have a gender, and here's your list of valid gender codes, things like that. But typically also up in the upper right there, when you're looking at the golden record itself, it tends to be flattened out, partly because often you want to get my golden record from a system via API. I want Donna Burbank and her name and her address and her gender and her date of birth and whatever else I'm tracking as master data all in one record, right? So it's kind of both. You're both doing it in a relational way to get that data quality and the rules, but then the actual golden record itself is typically just all smushed back together, which you do a lot. And I hear that, and I get annoyed by it when folks are like, no, relational is dumb and everything should be flattened and dimensional is better. Like they all just have their purposes. Folks that want a nice flattened data set, well, I would too, but someone had to take it apart into the pieces to clean them to put them back together again, right? You're not going to get nice, clean, lists of addresses when all the data from its source is always flattened out, because I don't want to do a third normal form class, but by breaking it out into its component parts, you're able to store them once and reuse it, so you can get to that clarity. So I think master data is often a good example of that, where it's kind of both relational and kind of both flattened out at the same time. And flattened is just that you put all the attributes back together again. Okay, motoring along. Graph databases, again, they have structure and they have semantic meaning, so therefore they're data models. If you haven't used a graph, I think they're very cool and have very powerful. So when we talked about master data, and I have all my correct nodes, right? And so again, it isn't either or. I want to see a graph relationship, which can be good about, say, social networks. Donna Burbank's my customer. She has a gazillion friends because she's awesome. And when she buys this new shirt, all her friends also buy the shirt. So I really want to understand the social network patterns of Donna, because when she buys things, people listen, because these data modelers are cool and everyone follows them, right? It can also be fraud detection. I'm seeing patterns, right? I'm seeing that, wow, there have been 47 credit cards all purchasing something from the same IP address. Probably not one person with 47 credit cards, probably fraud, right? So things like that. So super powerful. My little plug for things like good old-fashioned relational databases. You can't get a lot of that value if the data isn't clean, and to clean you need things like master data. So the nice thing about a graph data model is that some of the limitations of relational are these constraints, right? I have a very formal structure of billing address and shipping address and what these rules mean, but also there's many relationships, right? That a customer can be the owner of an account. They oh, I probably need a better example, right? There's different relationships. I can be the sister of someone, I can be the wife of somebody else, I could be, right? There's different relationships between different nodes, right? So in a graph, the relationships themselves are more first order constructs with semantic meaning. So you can say, a customer is an owner of account, but canceled an account or has these different relationships. So you can have some of that semantic meaning. So again, yes, they're data models because they have both structure and semantic meaning and a super interesting and helpful use case, which is different than some of those others. And again, any organization is going to have several of these because you have several use cases. Typically, none of these is inherently better than the other. They're better for a particular reason or use case, right? So motoring along. This one you might be like, what? We're talking about a modern data architecture, and you go back to something like EDI or electronic data exchange, and I find this interesting because I work with I feel honored actually to be working with some of the largest companies in the planet, with also small nonprofits, and I get to see a lot of real world what people are using, right? So a lot of the things I've shown maybe are kind of next generation. Does all the clients I work with have vector databases? No, very, very small subset. Are folks using relational databases? Yes. EDI is one of those things that a lot of folks are using and almost don't even realize that, yeah, that's the data. I sometimes and maybe often get pushback. Oh, we can't do data modeling. That's just pie in the sky. You want people to actually agree on a common definition and structure and things like that. And then I'll be working with someone like, oh, yeah, well, I got to put it in this EDI format because I got to share my claims with providers. And it's, a format 831 or whatever it is. And what is that? Well, it's a standard structure and a standard format and semantic meaning. And often it's folks that I'll be working with an industry um, that is very, you don't hear a lot about in the dataversities, isn't finance or isn't government, and they're just getting this stuff done. They're doing it, and they did it out of necessity and practicality and quality. That, oh yeah, we're working with another vendor and we have to share our oil well locations. Of course, we need it in the same location, or we want to send an invoice to someone. You got to have it in the same format, right? So yes, and that's absolutely data model. So EDI often is a flat file type format. There's a lot of other file exchange formats, XML, JSON, et cetera, right? This is just an example. But this is one that it's so just sort of embedded in an org, we often even forget to think about it, right? But and that's been around forever. But that is kind of the absolute what a data model is. It's a common structure and it's a common format. And I think we don't talk enough, or at least we do, but like in a lot of these webinars, we get so focused on our own organization. A lot of the data exchange, especially now with data products and monetizing data is across enterprises, right? It's not just everything we are doing ourselves. We're talking to other people, which makes it even more complex of what do we mean by a customer and things like that. So thought I'd throw that in there as a little bit, maybe old school, but used all the time in terms of data models. Okay, that was whirlwind. I talk fast and that was a lot of stuff. And I know some of you, because we data modelers are passionate and we're motivated and we love data models or we hate data models. And probably several of you are like, what? But you didn't include, you're right. I didn't include every option. UML is in there. There's plenty of things that are not. But I hope, and some of you others are probably like, okay, I get it, Donna, could you stop showing all these examples, right? But I hope it was helpful, but you're seeing a pattern. So happy to hear other ways people are using models. Isn't necessarily that I forgot. I just, the certain limitation of attention and time in a webinar. So hopefully you kind of get the idea that there is a pattern and why data models are everywhere. And in this new world of AI and machine learning, of they're more important, not less, right? Because again, if you want to communicate and you want to communicate across machines, even more so, you need a common structure and common semantics. So, it's kind of that, kind of hate the left brain, right brain. Is it too simplistic? But really, it's that same idea, is that a data model is going to have your technical structure and data format, but also that business meaning and context. And a good data model pattern, a good data model development is going to have those both. Not only what I mean by a customer, to use that ubiquitous overused example, but how am I structuring? What's the hierarchy around customer? What's the length of the data type in the customer name? And gosh, I was at a conference in Iceland actually earlier this week. And gosh, we're a fun group, us data, and the coffee talk, we actually had a whole like 15 minutes on name formats. I know we're a fun crowd. And the things we've seen was something as simple as quote first name and last name, or first name and surname, in terms of, do you have to have a first name and surname? Is there someone with a first name with one character or letters in their name, right? And so it's both the context of what we even mean by a family name, and then also the structure and format. And anything that's simple probably has some complexity to it. So that's why we have these things called data models. So there's that. So yeah, we kind of mentioned this, that especially in kind of going back to that strategy approach, as you're becoming more data driven, with data being your strategic differentiator. And I want to pause there a little bit, because I'm not saying don't use out of the box software. Don't use data models that, can give you ideas from an industry standard perspective. You're not the only person that's ever modeled an address. I'm not saying start everything from scratch. However, your customer base may have very different addresses. Do you have international addresses? Do you have Army addresses? Do you, et cetera, et cetera? Ask the questions. It doesn't mean that everything has to be different and unique, but I bet you some of those things that make your company unique also make your data model unique, right? We're the only people who ship packages to the moon. So we use GPS coordinates or whatever you use on the moon, right? So you can't just use an out of the box data model, because it's good for communication, and it's both for that, data structure and semantic meaning. And there's a whole lot of different ways to structure data for different purposes. That's why there's different data models and different types of models. So if you found this interesting, hopefully you can join us in July, where we'll talk not only about data architecture, but enterprise architecture. Because gosh, we had a whole webinar on just modeling data, but now let's try to model process and capabilities and org structure and all of that, which are also super important to your data strategy. So we'll nerd out about that next month. Blatant plug as a sponsor, we are at Global Data Strategy. Love data models, do this all the time, can help you with your data architecture. Don't hesitate to either go to our website or reach out to me directly, and my email is on the second slide. And with that, I will pass it over to Shannon for questions, thoughts, and ideas. Over to you.
Anna, thank you so much for this great presentation, as always. And I love that you're an influencer. I mean, I love that. Um, and if you have questions for Donna, feel free to put them in the Q&A panel. Just a reminder, to answer the most commonly asked questions, I will send a follow-up email by end of day Monday for this webinar, with links to the slides and links to the recording. So diving in here, Donna, lots of great questions coming in. Traditionally, conceptual, logical, and physical data models have been used to design relational databases. As you indicated, the modern data environment includes various types of non-relational databases, document, key, value, graph, etc. Can these non-relational data stores also benefit from conceptual, logical, and physical modeling? And B, do standard notations techniques exist for these different types of non-relational data models?
Great question. Yeah, one we think of a lot. I think at the conceptual level, absolutely, they're helpful, and even at the logical, I think still tends to be a little bit more on the relationally side. At the conceptual level, Absolutely, because you're getting to those core business rules, and those business rules have nothing to do with how the database is stored, right? So what is a customer? What's the product? What are these rules? But it's also getting at how you might visualize that. There are a lot of other notations. Gosh, at this conference this week, we had a bunch of people arguing about that too. Some show better examples. You know, there's fact-based modeling, there's ORM, there's different ways, there's UML that can get to maybe some of the ones that aren't your typical ER model can actually do a little better job at showing sample values and things like that. And so, yeah, at the physical level, I think is where you differentiate. And then I think, but starting, I think at that core with a conceptual, you're getting to some of those core. What do we even mean by these terms and how the business rules fit together? As you get into different use cases, you may use different notations. UML kind of can get into maybe some of the process around it and things like that. But I think yes, do it. I would rather people do it. Gosh, I have a whole webinar on this. Like I've done conceptual data models with sticky notes on a whiteboard and some lines, and is things line exactly right with cardinality and things. Does cardinality make sense in this particular use case? Maybe not. So it's better to even get to some of that. But it's definitely some where the I can talk the physical is tend to, is it a hierarchical model? Is it graph? Things like that. That's where some of those models tend to differentiate. But great question.
Gee, thank you. So, Donna, how should data models be cataloged and governed? I mean, how many data models are needed to cover a use case?
I love that question. I think they should definitely be part of the data governance process, which generally involves the business, especially at the business level. They are ongoing, living, breathing documents, and I see it happen all the time. And if you don't believe me, keep trying or talk to me about how you get that buy-in. I was at a data governance meeting at a client the other day, and I mean, these were business people. It was like HR and finance, and someone brought up something about how the departments are changing and how we do billing, and someone said, "Do we need to update the data model for that?" Like literally, people start thinking that way because you're drawing out and you're whiteboarding out the business. So as the business change and rules change, updating that conceptual data model or logical bits tends to draw everything else. And definitely at your physical level, I'm a fan. I know it seems to take that extra step, but in the long run is easier. Can you do model-driven development? I'm going to create a database, make the change in the model, and or and kind of work that way. Having an entire model repository, I'm a big fan of. So yeah, at all levels they should be used. They should be versioned and governed. And then when other governance topics come up and there's going to be a change in data, that question of how might it impact the model should come up because it's going to impact the systems and reporting and things like that.
Thank you. So there's so many great questions here, and we've got some time left, so I'm trying to slip in as many as possible. So Donna, in the process of data modeling, what role do you see playing in data lakehouses?
So I did uh, kind of cover that. See if I can jump back. So a data lakehouse is kind of the best of both worlds between a data warehouse and a data lake. And so if it gets annoying, I won't jump back. But maybe I can find it. When we were kind of talking about the pattern is where you land it in the raw. So your operational data is going to be modeled how it is. In that raw or landing, which is kind of the lake part of your lake house, I would say don't model it there. It shouldn't be modeled. It's modeled like the source. So it's going to look like your ERP system. And then, Databricks has their medallion architecture, which I kind of roll my eyes. It's the same. You land it, you stage it, you transform it. And I did, if anyone hasn't called me out in the chat, I missed some layers. Typically you go to landing and then maybe a staging before it doesn't magically appear, sorry, in the data warehouse. But I would not model the lake, maybe folder structures and things like that to kind of tag some things. But typically it's landed in the lake to keep it as its raw, so you have that, and then you transform it. In this case, a warehouse, it can be transformed into other modeling types. But that's your almost classic, the source modeling, raw lake stays in its raw format, and then you structure, in this case, for a warehouse in different formats. Hopefully I answered that.
I
All
believe
right.
so. Yeah, but
Okay.
definitely, feel free to add additional questions if you have more in for that question. So what would you recommend flat structure, a single table for every report versus star schema in Databricks in cloud?
I'm I'm not sure I understood the Databricks analogy there, but so a Databricks is that they're common with that data lakehouse architecture. So the one I just described, they support very, very well. That's what they kind of call the medallion architecture. So, your bronze, silver, gold, and you're kind of adding transformation. Flattened are great, but I think flattened is more on the, if I'm kind of, you can't see my hands, but kind of from left to right. Left is your source and you transform it. Flattening it out is great for an analytics team. If I'm a data scientist or even I'm just a human, I probably want to see it flattened, but it's kind of the point I made before. You have to take it apart and clean all this, like your Lego set. Oh, what a horrible analogy. But you take out all the Legos and you wash them and everything before you put them back together again to make the thing, right? So if you don't keep them clean, you're not gonna be able to have that nice flattened. So I generally see flattened not as a storage mechanism, but as a analytics mechanism. It's great for the final product, but to get to that final product, usually those other steps are doing all the hard work there to get it. So it's, and my the example I gave before of Donna Burbank with my address and all my the sports I like and everything else all in one big flat table is great, but that's not a great way to store it to make sure that, the fact that I like skiing and handball are drop down lists. Okay, that was a long-winded answer to that question. So that's
Oh,
it.
I like it. Yeah. And we've got about 4 minutes left, so we've got a couple other additional questions. I'll try to slip in here. What do you think the information from data sources should be first reaching data marts or data warehouse?
Chicken or egg? I typically, and I would say it's not even just me, but kind of, well, yeah, yeah, I would say warehouse, right? Because warehouse is getting that sort of your standard conform dimensions, right? Then you can kind of break off pieces of that. And in some ways, mhm, you could say, and I'll probably get people fighting with me, your semantic layers or your cubes are almost like view or subsets of your warehouse. So, right, so the example might be in my warehouse, I have my conform dimensions. Where did I have my warehouse picture? Making everyone dizzy. Of customers, products, regions, right? And then finance wants their own mark that has customers and credit terms and things like that. But you still want to have the same customer table, right? And if you do the marks first, you tend to, I mean, it can be done, but you sort of lose that idea of the conform dimension where it's that one source of truth. So I would typically say do your warehouse first, and then these marks can kind of, I know it's not the same as a view, but the your cube level or your physical marked from the warehouse because you can kind of take advantage of things like those conformed mentioned. My 2 cents.
Perfect. And I think we have time for just for the last question. What can be automated in reference data tables?
What can be automated in reference data tables? Well, the fact that you have reference data tables allows you to automate, right? So, I mentioned it before, your classic, anything that's a list of things, whether it's external or internal, my list of department codes, make it a drop-down list. That's automated. If, I have the state codes and we only operate in Wisconsin, I can even make that the default value that's hard to change, right? Um, Automation in terms of sometimes there's third-party data sets like state codes, country codes, there's ISO country codes. I would recommend don't go create your own list of countries. Switzerland CH and US is US, and that's not a great thing to reinvent the wheel. So you can either purchase or just, those don't change very often. Just use the reference codes externally, and that can be automated too. These are the valid sets, or medical codes and claims codes and things like that. Often there's kind of an external source of that you don't have to do that work. You just link to it. But you also have internal. Someone asked me, actually the last DATAVERSITY conference, that was just that. Isn't reference data external data you bring in? And it can be, but it's not only that, right? You have your own department codes, your own region codes, your own, maybe how you look at gender or something like that in your system. So that is that.
Perfect. Well, Donna, thank you so much for this presentation, but I'm afraid that is all the time that we have for today. Thanks to all of our attendees for being so engaged in everything that we do. And again, just a reminder, I will send a follow-up email by end of day Monday with links to the slides and links to the recording. Thanks, everyone. I hope you all have a great day.
Thank you.